Hey everyone, are you ready for a deep dive into something truly extraordinary?
I am.
Today we're looking at OmniHuman,
Oh, yeah.
this new AI model that's making waves in the world of animation.
It's really cool.
You sent over the research paper omnihuman.pdf,
Right.
and I have to say the possibilities are pretty amazing.
They are amazing.
Just imagine, creating videos of people doing just about anything, talking, even playing instruments,
Yeah.
all from a single image.
You got it.
It's like bringing pictures to life.
It is.
But I'm curious what makes this different from
Right.
what we've seen before in animation.
Yeah, that's a good question.
Like, what's so special about this?
Well, to understand it, you have to know
Okay.
how tricky it's been to train AI models for human animation.
Okay.
It's always been a data problem.
Oh, really?
AI needs tons of data to learn, right?
Right.
But getting clean, usable data for human movement,
Yeah.
it's like finding a needle in a haystack.
Why is that?
Because people move in all sorts of unpredictable ways.
Right. Like, we're not robots.
Exactly. Think about it. Audio data is great for facial expressions, but it doesn't tell us much about how someone moves their body.
Oh, I see.
And pose data from videos is helpful,
Okay.
but you have to filter out all the noise, the shaky footage, people walking in the background, all that stuff.
Yeah.
And all that filtering means we're throwing away potentially valuable data.
So even though there's a lot of data out there,
Yeah.
most of it isn't quite right for training these AI models.
Right.
That's where OmniHuman comes in.
Yeah.
With this really cool idea
Okay.
called Omni-conditions training. I'm intrigued.
Okay.
Walk me through it.
Okay. Imagine you're a chef who can use any combination of ingredients
Okay.
to create a delicious dish.
Yeah.
That's what OmniHuman does with data. It uses multiple signals, text, audio, and poses
Yeah.
in any combination to train the model.
So instead of needing perfect data for every aspect of the animation, right?
It can use what it learns from one type of data to fill in the gaps for others.
Exactly.
That's pretty clever.
Yeah, it is. And the paper highlights two key principles
Okay.
behind this approach. First, they found that stronger conditions, like clear pose data, can be used to train on weaker conditions, like text descriptions.
So even data that wouldn't normally be good enough on its own
Yeah,
can still contribute to the learning process.
exactly. And the second principle is all about balance.
Oh, interesting.
The researchers found that they needed to adjust the training ratios
Okay.
based on the strength of each condition.
What does that mean in practice?
Sure, let's say you have a video with great audio,
Okay.
but the person's body is mostly obscured.
Okay. Yeah.
OmniHuman can still use that audio to train the model on how the face moves during speech, even though the pose data isn't perfect.
Yeah.
And it does this by adjusting how much it relies on each type of data during training. So it's like a balancing act, making sure the model gets the right mix of information from all these different sources.
It is. It's very complex.
That sounds incredibly complex.
Yeah,
Wow, but the results are truly impressive.
they are.
They measured the model's performance using a bunch of metrics, FIE, FED, SYNC-C.
Right.
Think of these as ways to score how realistic
Yeah.
and smooth an animation looks, just like judges score figure skaters on their technical skills and artistry.
Exactly.
Okay, so based on those scores, how does OmniHuman stack up against other models?
Well, it consistently outperforms models specifically designed for certain types of animation,
Okay.
whether it's just the face or the whole body.
Yeah.
And here's the kicker. It does all of this with a single model. Other methods often need different models for different body types, which gets really complicated.
So it's like a multi-talented performer who can sing, dance, and act all at an incredibly high level.
Yeah, you got it.
But I'm a visual person.
No.
Let's move beyond these scores
Yeah.
and look at what OmniHuman can actually do.
Yeah, let's look at some examples.
Okay, I'm already picturing some cool stuff.
Yeah,
Where should we start?
let's jump into figures 7, 8, and 9 in the paper.
Okay.
They showcase the variety of animations OmniHuman can create. But the real star of the show is how well it captures realistic human motion.
Okay.
The little details that make a movement feel natural.
You've got my attention. Give me the highlights.
So we see characters playing musical instruments,
Okay.
making gestures while holding objects,
Cool.
all with this incredibly natural flow. There's even an example of animating an anime character,
Really?
and it maintains that distinct anime style of movement.
Wow, it's really capturing the nuance of how different people move.
It is.
That's what makes it so believable.
Exactly what sets this apart from previous approaches is that OmniHuman can actually maintain the motion style of the image you feed it.
Huh.
So if you input an image of a dancer, the animation will move with that same fluidity and grace.
That's mind-blowing. Okay, you've definitely convinced me that this is something special, but I'm curious, why is this approach to data so significant in the bigger picture?
That's a great question, and it gets to the heart of what makes OmniHuman so exciting. Let me explain.
Perfect part 2 coming up. Right, you're about to explain why OmniHuman's approach to data is so significant. I'm all ears.
Well, it's not just about animation. This idea of scaling data sets, being able to use all the data, even the messy stuff, could be a game changer for AI in general. Think about it.
Okay.
Most AI models today are trained on these huge, carefully curated data sets.
Yeah.
It takes a ton of time and effort to filter and clean all that data, and we still end up throwing a lot away.
So OmniHuman is showing us that there's a better way. Instead of being so picky about the data,
Exactly.
we can teach AI to learn from a wider variety of sources.
Yeah, and the researchers really wanted to test this idea.
Okay.
They did a bunch of experiments where they intentionally limited the data,
Okay.
kind of like tying one hand behind OmniHuman's back.
Okay. I'm always up for a good science experiment. What did they do?
They tried training the model using only the perfect data,
Okay.
the kind of clean filtered audio and pose data that other models rely on. They basically ignored that first principle of using data from weaker conditions.
So they took away OmniHuman's secret weapon, the ability to use all those different types of data. What happened?
The results were pretty underwhelming. The animations lost a lot of their dynamism and expressiveness.
Oh, really?
And in some cases, the model completely failed to generate a believable animation,
Oh, wow.
especially when they use more complex images as input.
So it's like trying to learn a language by only studying grammar rules.
Yeah.
You might be able to form technically correct sentences,
Right.
but you'll never be able to have a natural flowing conversation.
That's a perfect analogy.
Yeah.
They also experimented with the ratios,
Okay.
how much of each type of data they fed into the model.
Did they find a magic formula?
They did. It turns out that a 50-50 split works best. Half of the data came from those strong conditions, the clear audio and poses, and the other half came from weaker conditions, like text descriptions.
So balance is key. Too much of one type of data throws things off.
Exactly. This reinforces that second principle.
Okay.
The stronger the condition, the less you need to rely on it during training. They saw this especially with the pose data.
Okay.
Too much reliance on perfect poses actually made the animation stiff and repetitive,
Interesting.
especially when the model was only using audio as input.
So even though pose data is very precise, you don't want the model to get too hung up on it.
Right.
It needs to be able to learn from other signals as well to really understand human motion.
It's like learning to dance by watching videos.
Okay.
You can learn the steps perfectly,
Yeah.
but if you don't feel the music and move with your own style,
Right.
it's not going to look natural.
Okay, that makes sense. Did they see a similar pattern with other types of data?
They did. They also experimented with the appearance condition.
Yep.
That's how the model learns to preserve the identity and background from the reference image.
Uh-huh.
Making sure the animated person actually looks like the person in the photo.
Right, keeping those visual details consistent. So what happened when they played around with the amount of reference image data?
More was definitely better.
Okay.
When they used a higher ratio of reference images,
Yeah.
the animations were more accurate
Yeah.
and stayed true to the original image over time.
Mm-hmm.
But when that ratio was too low, they started to see some weird stuff happening.
Like what?
The animation would start to drift away from the original image.
Oh.
You'd see things like noise in the background or the person's appearance changing slightly.
Really?
Like a photocopy that gets blurrier with each copy.
Like a visual game of telephone. It's fascinating how those little details can make such a difference. So we've seen how OmniHuman works, we've seen the impressive results, and we've explored why this approach to data is so unique.
We've only scratched the surface.
Okay, color me intrigued. What else is there?
Well, now that we understand the how, I think it's time we start talking about the why.
Perfect part 3 coming up.
Yeah.
Okay, we've explored the how of OmniHuman,
Right.
the technical nuts and bolts of this amazing AI.
Yeah,
But you said it's time to talk about the why.
I did.
Why should we care about this beyond just cool animations?
Because this goes way beyond making pretty pictures move.
Okay.
OmniHuman is showing us a glimpse into the future of AI. And it's a future where AI can learn from the world in a much more human way.
Okay, I'm listening. Paint me a picture of this future.
Imagine a world where creating realistic animations is as easy as writing a story.
Oh, wow.
You could describe a scene, a character, an emotion,
Yeah.
and the AI would bring it to life
Okay.
with incredible detail and nuance.
So instead of needing a whole team of animators and programmers, anyone could be a storyteller.
Exactly.
That's pretty powerful.
It is, and think about the impact on industries like filmmaking and video games.
Oh, yeah.
We could create incredibly immersive experiences limited only by our imaginations.
I'm already picturing video game characters that react and move with such realism. It's like you're interacting with real people.
Right, or imagine being able to create personalized avatars
Oh, wow.
that capture your unique movements and expression.
Okay.
It would revolutionize how we interact online.
So we're not just talking about entertainment. This could change how we connect with each other on a fundamental level.
Absolutely.
Yeah.
And this is just the beginning. As AI models like OmniHuman become more sophisticated and accessible,
Yeah.
the possibilities are truly endless.
It's exciting, but also a little daunting, right? Like,
Right.
we're opening up this whole new realm of possibilities, but we don't even know what all the implications are yet.
That's true. It's important to remember that every powerful tool can be used for good or for ill.
So as we dive deeper into this future,
Right.
we need to be mindful of the potential downsides as well.
Exactly. We need to have open and honest conversations about the ethical considerations, about the potential for misuse. But we also need to embrace the potential for good, the ways this technology could improve our lives
Yeah.
and help us tell stories in ways we never thought possible.
Well said. It sounds like OmniHuman is giving us a lot to think about, both in terms of the amazing things it can do and the questions it raises about the future.
It is. I think that's the hallmark of truly groundbreaking technology. It pushes us to expand our thinking and imagine what's possible.
Okay, deep divers, we've covered a lot of ground today. We've explored the technical marvels of OmniHuman, its unique approach to data, and its potential to reshape entire industries.
We have, and we've touched on some of the bigger questions this technology raises about the future of AI and its role in our lives.
So before we wrap up, I want to leave you with one final thought to ponder.
Okay.
Imagine a world where anyone can create personalized, interactive stories,
Yeah,
featuring lifelike virtual characters. What kind of stories would you tell?
that's a great question.
That's all the time we have for today's deep dive, but I hope this conversation has inspired you to think about the incredible possibilities of AI and the future we're creating together.
Until next time, keep exploring, keep questioning, and keep diving deep.